Hey everyone! Okay, so it is almost March. We're getting out of February. We're almost there, right? Spring is right around the corner. We're having some crazy weather, but aside from all of that, we still have to do some math. So let's get to mathing tonight with your lovely star host, Miss Pryia. I forget that I don't have to touch the computer, I have to touch the iPad. So, oh no. Okay, so this might be a little bit disastrous. Give me one moment and I will fix this for everybody because now we can't see any of the stuff that we're doing. Okay, in less than 60 seconds, I promise you, you guys can time me on this, I will have this all ready and good to go. So let's just chat about what we can see. There's always some questions that you guys have for me, so why don't we go ahead and throw those questions into the chat because I can still read while I'm doing this. I promise you I can do that. And then in no time, I will have this back up and ready to go. So one thing about math that a lot of people often forget is math is more than just knowing the process, right? Math is about not just the process, but also the definitions. If you can't speak the language of math, then you're probably not going to be able to answer the questions that are being asked to you, right? Everything always falls back on, do you understand what's going on? And if you can understand what's going on, then you can understand a lot more than you think. So I'm going to stop sharing really quick. It's my whole big face. Hi, guys. And I'm going to bring back up a different PowerPoint because the one that we have opened didn't like us. And I'm going to open it up. I told you less than 60 seconds. I'm like working against the clock right now. Making promises over here. I'm making promises over here. And wham, bam, please, thank you, ma'am. All right, here we go. I'm going to share again. Boop, 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 boop. Hi. Share screen. Okay, everyone cross your fingers. You can't see my screen. Okay, one more time. Share screen. All right. I know I promised 60 seconds. I lied to you. I'm sorry. We were having small issues earlier as well, and I don't know why it just doesn't like me. Okay, here we go. Boom. As promised, I'm back. All right, so we're going to go through question one. Question one's about probability and statistics. I promised you I'd be better at telling you what type of problem it is. And normally you guys see word problems and what happens? We shut down, right? We go into this like abyss and we don't want to come back out. We're just like words. Words and math don't belong together. But why not? They do. They're not bad. It's not a bad combo. I know. Coming from someone that does math all the time, I'm telling you words and math actually do go together. Well, let's go ahead and read the question. It says, a young man visits the library and takes 5 books off the same shelf. So all we know right now is what? 5 books. He took 5 books off of this shelf that he found, right? And after he was finished, he decided to ignore the library sign and he just reshelved these books as he pleased. So he took all of those 5 books and he put them back on the shelf that he took them off of. Then we're asked this question. Here we go. How many different ways could he reshelve the books? Okay, who's staring at it going, I don't know. Why do you ask me these questions, Pryia? Why do you drag me to these places and ask me all of these questions? Because it's not that bad, I promise. Okay, ready? Does order matter? What do I mean? What do we have? Right now, we have 5 books. What else do we know? We know that off of the same shelf, he took those 5 books. What does that tell us? That the books went back onto that shelf. So there are 5 slots to where these books can now fit. Let's go ahead and draw our books that are on our shelf. I'm just going to make like little boxes for our books. So we have 1, 2, 3, 4, and 5. All right, those are our 5 books. Well, if order doesn't matter, which is correct, does it matter in the sense that if I put book 1 here, can book 1 also go in the second place? No, it doesn't matter how I place the books, but it does matter in the sense that one book cannot be placed in 2 slots at the same time. So essentially, order matters. I cannot place book 1 in more than one place at a time. So we look back at the question and we go, okay, well, what do I know? I know that I have 5 places to place these books. So I made my 5 slots. Those are my spaces that I'm going to put these lovely 5 books into. So I'm going to draw my books out. 1, 2, 3, 4, and 5. Okay, now that I have my books, right now, to place a book into slot 1, how many books can I choose from? Right now, to place a book into slot 1, how many books can I choose from? I should hear you yelling 5. Wherever you are, I should hear you yelling 5. Right now, I have 5 books to choose from to place into the first slot. So after a book goes there, how many books do I have left? After a book goes there, how many books do I have left? And you keep playing the game until you run out of places to put your books, or you run out of books, right? So now we have to ask ourselves, how do we solve the problem? Are we going to add these? Are we going to multiply them? Are we going to divide them? What are we doing? What are we doing here to solve this problem? I love the interaction in the chat. I love when you guys tell me stuff. We're going to multiply them, okay? We have to multiply this in order to figure out what's going on, right? We need our probability. So 5 books can go in the first slot, 4 books in the second slot, 3, then 2, then 1. And in order to get our answer, we have to multiply them together. Put the calculator down. Did you hear me? Put the calculator down. I can see you. Put it down, put it down. We are going to do this problem without a calculator. Are you ready? Here we go. What is 5 times 4? 20. What is 3 times 2? 6. And anything times 1 just is the number, right? Now, what is 2 times 6? 12. But we had a 0. Add your 0. There are 120 ways to put those books back on the shelf. Yay, no calculator. Okay, I want to talk about the calculator really quick. Those of you who get a handheld calculator, great, right? We don't really have to worry about what I'm about to say. But those of you who are getting the calculator on the computer screen, every time you need that calculator, you have to open it up, which means you're taking up time from your test, which means you have less time to solve some problems. So let's try getting better at our mental/paper math, and let's not worry about the calculators too much. Deal? Deal. All right, so 120. I see a lot of you are saying you got that answer. Kudos to you. Okay, so what about Mary? This is one of those bonus problems that I like to give you guys. Mary is making breakfast for her kids, nieces, and nephews. So there's a lot of children in her house. And she hears the 8 children coming into the kitchen. How many people do we have coming to get breakfast? 8 children coming into the kitchen. While those children are coming into the kitchen, what's going on in Mary's mind? Mary wants to know, she's wondering to herself, how many different ways she could serve each child their breakfast, given she only serves one child at a time. So how many different ways can she serve these children breakfast if they line up to get breakfast from her, right? So let's draw it out. Let's give you guys a visual aid. Here is Mary. There's Mary. Should probably name her Mary. Mary. And then we have 8 children behind her. 1, 2, 3, 4, 5, 6, 7, 8. Okay, they're all different sizes, right? So these are our 8 children. Now they're coming towards her to get breakfast. This is very similar like the last problem. When she serves these children, how many children does she have the potential of serving first? 8. Then she has 7, 6, 5, 4, 3, 2, and 1 left. So just like before, the part that mattered was if you serve one child, you cannot serve them again. You have to get through your children, right? You cannot keep serving the same child because if you keep serving the same child, we will never get through breakfast, right? All right, so this one was a little bit more difficult. I'll let you pick up the calculator for this one. But before you pick up the calculator, you should try to reduce these numbers so there's less error in the calculator. The less you have to put into the calculator, the less error you probably can make. And I will tell you that the lovely amount of combinations that Mary can make is 40,320 different ways to serve these children. I know it's a really large number. I love large numbers because it freaks you guys out. All right, you know the deal. If you have any questions, put it in the chat and I will be happy to take care of it. Question number 2. It's another probability and statistics problem. And here we are given 5 red balls, 4 green balls, and 1 orange ball. So we have 5 red, 4 green, 1 orange. And a ball is drawn at random and then replaced before a second ball is selected. This is good information. We need to know this. What is the probability that the first ball selected was orange and the second ball was orange? Okay, so now we have to go back. A lot of you are asking, well, is it combination or permutation? These are one of those problems where I prefer to not say if it's either. Why? Because these problems can be solved a very specific way. We are doing what is the probability of selecting a ball, and whatever I do to it, what is the next probability? So what's happening is I have my 2 fractions that I will need to multiply. My first fraction is always going to be what you start with. Your second fraction is going to be what you have now. This is important to know because when you're doing the problem, it always matters how you put your information in. So our color goes at the top. We can do orange for orange. O-R-A-N-G-E. O-R-A-N-G-E. And remember, your total always goes in the denominator. All right, so now that we're looking at this, how many orange balls do we start with? We start with 1 orange ball. What do they tell us? They tell us it is drawn at random, but then replaced. So are we keeping it? Are we changing the total? No, we are not changing the total. Right now, we have how many balls? 5 and 4 is 9, plus 1 is 10. So if we take 1 out and we put it back, how many orange balls do we have and how many in total do we have? We still have 1 and we still have 10. If they said not replaced, without replacement, those words mean you take it and you keep it, right? So here we have 1 out of 10. We take it out, we put it back, and we still have a 1 out of 10 chance to get an orange ball. Now, when we multiply this, remember you multiply the numerators together. 1 times 1 is 1. You multiply your denominators together, and 10 times 10 is 100 to give you, wham, bam, thank you, ma'am, D. So you have to be careful with how these problems are worded. Problems like this, when you're picking and you're choosing, especially like with random items like that, I don't like putting combination and permutation here. And it's because it sometimes creates more issues than simply solving the problem, right? We can go down the road of what's going on and what happened to figure out permutation combination, or we can simply write 2 fractions, know that we have to multiply them, and know that based on what the situation is, will tell us how we get our answer out. So remember, 1 is the number of orange balls that we have. If the problem read green balls, we would put 4. Or red, we would put 5. It's whatever amount that we have. So let's go ahead and try another one. I always give you guys a bonus problem on this. So I didn't write it out, but we still have the same amount of stuff. We have 5 red. Let's say we have 4 green. And we have 1 orange. Okay? I'll put orange so it's not a 0. Okay, those are what we have. We have 5 red, 4 green, and 1 orange. So let's go ahead and say that a ball is drawn at random. Oh, that's not how you spell random. And without replacing it, another ball is drawn. Okay, let's go ahead and say that the first ball is orange and the second ball is red. So now we're going to do the probability of an orange and a red. So remember, we start with our fractions. Our totals always go at the bottom. And our colors go at the top. So our first color is orange and our second color is red. Right. Now, what do we start with? We start with 1 orange and how many in total? 10. Do I keep the orange ball or do I put it back? Do I keep the orange ball or do I put it back? You put it in your pocket. You keep it. It says without replacing it. You keep it, keep it, keep it. I know, I tried to trick you. So we will have 1 less total ball to choose from because our number has changed. Well, how many red balls do we have? We still have 5. We haven't chosen any of the red balls. So now when we multiply, remember multiply straight, it will be 5 over 90. That can totally be reduced. What does 5 over 90 reduce to? That becomes a 1. That becomes a 2. It becomes 1 over 18. 5 over 90 reduces to 1 over 18. Okay, that's a great question. So what if it said choose a red and another red? I don't know why I erased the second red. Boop, boop, ba-doo. I love these questions. Okay, we're going to do 2 reds instead. So we're going to do red and another red. All right, so we're going to start with what we know. Process is the same, just the numbers are going to change. Totals are still going on the bottom, and colors are still going on the top. Now we have 2 reds. Okay, what are we starting with? We are starting with 5 of them. And how many do we have in total? 10. Now I select that red, and remember it says without replacing it. I'm going to put it in my pocket. I'm keeping it. How many red balls do I have now? 4. Remember, we started with 5. I took one out. I put it in my pocket. Here's the red ball. I put it in my pocket. Now I only have 4 left to choose from. Well, if I have 4 red balls and I have 1 less in total, I'll also have 9 to choose from. Right? Remember, you multiply straight. So 5 times 4 is 20. And 10 times 9 is 90. And that can reduce to 2/9. Great question. So if it's the same color, remember, you have 1 less of that color, so your numerator and your denominator is now going to change. Okay? If it's different colors and you're keeping it, only your denominator is going to change. And if you're not keeping anything at all, your denominator stays the same, and it's just based on whatever they're telling you to choose from in the numerator. Right? So there's lots of terms and conditions that go with this stuff. That's also why I just prefer to do the problem instead of identifying the problem. All right, you know what to do. If you have questions, put it in the chat. I'll be more than happy to answer it. So question number 3 is a geometry problem. This type of geometry you'll see in like middle high school. So this will kind of be like one of those more like upper level math questions. And they just want us to evaluate the measurement of CAD. Well, first things first, how do you read this? C goes to A, then to D. So our angle that we're looking for is right here. I'm gonna like color it green. That is angle CAD. All right, well, that's the guy we're looking for. Does anybody have any ideas on what's going on? I see a bunch of stuff going on. So am I kind of just taking this triangle here by itself? Is that what we're trying to do? We're trying to like find out that information? Nah, that guy looks too weird. I'm not trying to figure out what he's got going on. I'm going to figure out that guy, the big triangle. Why does the big triangle matter? Because I've got more information about it, right? And you want to go where you have more information. If you know nothing about soccer, you're not going to go watch a game about soccer and know everything that's going on. You have to learn the information. But if you know about football, you're really going to enjoy it. You're going to go there, right? So right now we're looking at this guy and we're going, okay, well, what do we know about him? We know that 90 degrees is in this corner because that's what that lovely square means. So that's 90 degrees. We know that the corner down here, that angle is 26 degrees. So we're going to add these together because the sum of all the angles in a triangle will always add to equal what? They will always add to equal 180 degrees. Yes, yes, yes. Okay, so if we have 2 of the 3 angles, this whole angle by itself, we can figure out what that whole thing is, right? So if we do 180 minus 90 minus 26, we get 64. Is that the answer we're looking for? It's an answer right here. Is that the answer we're looking for? No, it's not the answer we're looking for. I'm lying to you and I'm tricking you. It is not the answer we're looking for. 64 is not what we're looking for. 64 is two angles added together. But that's not the case here. They're asking us just for CAD. And remember, I did CAD in green. So what do we have to do? We have to figure out what this guy is here, what this angle is, this pink one that I just drew in. We have to figure out the measurement of that pink angle. How are we going to do that? How do we find the measurement of that pink angle? I'm going to change the color to blue. How do we find the measurement of the blue angle? Does anybody have any ideas on how to find the measurement of that blue angle? Okay, ready? We're going to get that angle by looking at the, oops, sorry. Try that again. Okay, I'm going to try it one more time. I promise I can do this. By looking at this triangle, that triangle, that lovely green triangle, is going to tell me what that angle at the top is. How do I know? I know a lot of things going on right now that we didn't talk about. I know that this side of the lovely highlighter green triangle and this side of the lovely highlighter green triangle are equal. And if those sides are equal, their opposite angles are also going to be equal, which means this part here and this part here are going to be the same measurement. And if we know that every triangle adds to be 180 degrees, for this triangle, I can do 180 degrees minus 90 because we have the lovely square in the corner telling us it's a 90-degree triangle to get 90 degrees. Well, that means that I have to split the 90 degrees evenly between those two angles, right? Because they're the sides. If the sides measure the same, then the angles are going to measure the same. And when I do 90 divided by 2, I'll get 45 degrees. So I now know that that lovely blue angle is 45 degrees. Well, 45 degrees still is not the angle that we are looking for. It is a part of the piece that we need. CAB, yes, that is a good description. I should be using my terms. Angle CAB is 45 degrees. But we need CAD, D for doggy. So remember earlier that 64 degrees, we left it in red because 64 meant the entire thing, right? That whole corner. 64 was that whole corner. Well, I only want CAD, but now I have CAB, and CAB is going to help me find CAD. So I'm going to do 64 minus my lovely 45 that we just found, and that is going to give me my angle CAD. CAD is what? 19 degrees. So when you see problems like this, where do we start? We start with what we know. Sometimes it's not always easier to break them into two triangles, right? Because here, our two triangles did not necessarily mean this triangle and this triangle. They're actually two similar triangles, but a little bit of the stuff were off, right? So when we look back at the problem, let's try solving it one more time together, do a good walkthrough. So our yellow highlighter triangle is the big triangle, right? From our big triangle, we know that we have to find the measurement of CAD. Angle CAD is that lovely green angle right here that we drew. Okay, so here is CAD. Now we're going to use this lovely yellow triangle to help us solve for what we need. We know that angle 26 and angle 90 because it has that perfect square in the corner, tells us it's a right angle. 90 and the whole top angle will add to equal 180 degrees. Well, if I subtract 90 and 26, I'll get 64. Well, 64 is the entire top angle. 64 is angle well, let's name the angle the way that they're naming them. DAB. That is angle DAB. Start at D, go up to A, go down to B. DAB. Well, I need that in order to help me solve to move forward. Now we have to look at our lovely highlighter green triangle. Our highlighter green triangle tells us two of the sides are equal, which tells us two of the angles are equal, which tells us that it is an isosceles triangle. So if we have 90 degrees, when we subtract 90 from 180, we're left with 90 degrees. We have to split that 90 degrees into both of those angles. Once we do that, we will get how much that angle is. And each of those angles that are missing here in the highlighter green triangle are going to be 45 degrees. Okay, well remember DAB, that entire top angle here, that red angle, that whole thing is 64. Well, we just found CAB to subtract from 64 to give us CAD. And that is how we get our answer, which is 19. Perfect. I know. It's like one of those you got to digest. Take your time. Number 4, trigonometry. I haven't done trig in a while, so I felt like it was something that I just needed to do. It is not a middles. It's not a middles. It is not a middle anything. It is a high school or college level type of problem, right? And in order to be able to do this problem, you need to know your identities. And if you don't know your identities, you will not be able to solve this problem. And you can try as much as you want, but you're not going to get anywhere. I promise. You have to know your identities. So first things first, we look at the problem. What do we see from the problem? We see secant, sine, tangent. I'll highlight them each in a different color. We see secant, sine, and tangent. All right, that gives us nothing to work off of because we don't know which one is a better form to go into. Well, I do know though that secant, an identity for secant, I can transform secant into what? Does anybody by chance know what I can change secant into? What can I change secant into based on my trig identities? 1 over cosine. I'm going to keep my thetas. So we have something to work with, right? We can't change our sine right now because there's nothing really to do with that guy. So we're just going to keep sine the same. But now the question is, what can I change my tangent into? And tangent is sine over cosine. Sine of theta over cosine of theta. Thing about this is you want to keep the sine over cosine in parentheses. Don't mess that up now, right? Because right now they are being multiplied. Don't forget. So now we go, okay, well, what do we have? We have 1 minus cosine minus sine times sine over cosine. Well, we treat this like a regular problem. We're going to put the sine of theta over 1, and we're going to multiply two fractions. We know how to multiply fractions, right? We get 1 over cosine theta minus sine times sine is sine squared of theta all over cosine of theta. Well, look at what happened there. Look at what happened. Can you tell me what just happened? This is stuff that when we're solving, we like to see stuff like this, right? Yeah. This is stuff that when we're solving, we like to see stuff like this. We have two fractions with the same denominator. I know, it's like crazy. When you have two fractions with the same denominator, you can go ahead and solve the problem. So what does this tell us? It tells us that we have 1 minus sine squared of theta all over cosine theta. Is that our answer? No, because it's not one of the answer choices. So what do we do now? There's an identity that we haven't yet talked about, and somebody needs to tell me the identity. What is it? What is it? What is it? I'm writing it out. I'm writing it out. What is it? It is cosine squared or sine squared plus sine squared or cosine squared. It doesn't matter the order because it's an addition. So cosine squared plus sine squared is equal to 1, which tells us, if I move my sine squared over to the other side, I can say that cosine squared is equal to 1 minus sine squared. Why do I want to say that? I want to say that because I can replace this entire numerator with my trig identity that says that it is now cosine squared of theta. So I have cosine squared of theta over cosine. Remember, we just took two fractions and we put them together. So I don't want to break my fractions up again. I don't want to go back to tangent. Tangent's not helping me solve the problem. Tangent doesn't have what I need, right? And it can't be tangent because tangent is sine over cosine, not sine squared. So you got to be careful. All right, now I have cosine squared over cosine. We're almost there. How many cosines do I have in the top? 2. I have 2 cosines. So another way to write this would be to say cosine theta times cosine theta all over cosine theta. Well, we like saying it like this because we know that anything over itself becomes 1. So it goes away, right? It goes away. It doesn't really go away. It just becomes a 1, so it goes away. And we're left with what? Cosine of theta in the numerator only, which is C. I know some of you are staring at this going, what just happened? You still have to apply the rules of algebra. I know, it's like crazy how this works. You still have to apply the rules of algebra. The only thing that changes is you're not using numbers and letters, you're just using kind of like words and symbols. So this problem would not be on the GKT. This is more advanced math than the GKT. This is more of the subject areas specifically targeted to math teachers. Can you include indefinite integrals with trig? I don't know that you can or you can't. I can say honestly, I've never seen them. I've never had to do them. That's a good question. I can always look it up. Go ahead and post that on our Facebook page, and I would be more than happy. I know they'll tag me in it, say that Pryia told me to say this, and I will definitely respond to you on Facebook and let you know some more information about that. I would like to know that answer too. That is a good question, Joseph. Thank you, Joseph. All right. No more questions. We're going to go to number 5. Number 5. This is a calculus problem. I know. I did like some GKT stuff earlier, and now I'm just going to like crazy math. You guys are staring at me going, what are you doing? This is more of the math-specific people again, right? This is calculus. You do not need this on the lower level math stuff. This is the higher level math, right? So here we go. We're being asked for a derivative. Derivatives How do you do derivatives? This is a basic derivative. It's a power rule derivative, right? In our power rule derivative, we're going to take our power and multiply it by our coefficient, and then we're going to take our power and subtract it by 1. So there's like a lot going on at the same time. And derivatives are normally represented by something that we call a prime. It's a tick mark. It's an apostrophe. So the prime, the derivative of that function, I'm going to take 3 and multiply it by 4. 3 times 4 is 12. Keep my t, and 3 minus 1 is 2. All right, now I'm going to do it again. My imaginary number right now is 1. So I'm going to do 1 times -6 is -6. Keep my t, and 1 minus 1 is 0. Okay, here's the question. Any variable to the 0 power is equal to what? Any variable to the 0 power, or anything, any number, any letter, anything to the 0 power is equal to what? 1. It is equal to 1. So right now what this says is 12t squared minus 6 times 1. All right, well, the best way I know how to write that would just be 12t squared minus 6. And that is the answer we're looking for. That has a t, that has a 15, that is a 15, and the answer is D. Calculus isn't that bad. I know, I think it's not that bad, but some of you are screaming at me going, oh, you're ridiculous. Okay, so here's a bonus question. We just found the derivative of the first problem, right? But this is a different problem. That's a different problem from the one we're about to do. What if they ask you for the second derivative? What if they ask you for the second derivative? I don't know. What if they ask you for the second derivative? Well, first you have to find the first derivative. You can't just skip steps. So the first derivative of this function, 4 times 7, 28. Take my t and subtract, so I'll get 6. It's 28t to the 6th. Now I'll have 4 times 6 is 24. 24t to the 3rd. And I don't take my 15. My 15 is a goodbye. We don't need him anymore. He no longer matters to us, right? He doesn't have a letter. He can't stick around. But now I take the derivative of my derivative, right? Remember, this is not GKT math. This is more advanced math. So I have to take the derivative of my already derived function. That is the second derivative. 6 times 28. 168 t to the 5th. 3 times -24 is -72 t squared. So our second derivative of what we were given is this guy. Right? They're not that bad. Let's keep going. Let's keep going. So here we have to find the sum. This is an algebra problem. This is, do you know what those things mean? And what do I mean by things? What are these things, these eyes? Who are they? Where did they come from? What are they doing? Does anybody know anything about these eyes? Can you help me? They're imaginary. Yeah, imaginary. What does that mean? It doesn't mean it doesn't exist. It's there. You can see it, right? It's not made up entirely. It just means it's not a real number. It is a complex number, right? And this is an algebra type of problem. So this is kind of like a free-for-all across the board, right? So these are little things that we always want to make sure that we know. So if that's imaginary, what do we do? Well, it's asking us to just create the sum. So let's go ahead and start with what we know. Remember, we're going to treat it like a variable and then do something if we can with it. So we have 7 plus 3i minus 8 plus 9i. Right? Well, we're going to combine like terms. 7 and negative 8 are going to go together to give us negative 1. And the 3 and the 9 are going to add to give us 12i. There's nothing else I can do with this. Yes, I could rewrite it because I is the same as saying the square root of a negative 1. But our answer choices don't have that in it, so I'm not going to rewrite it. I'm going to keep it the way that I have it, and I'm going to look for that as my answer choice. It is not D, C, or B, and it is definitely A. Ta-da! I know. Math is fun when you do math with me. All right. Well, oh, I didn't write it out on here. But let's say we're not doing the sum of that stuff. Let's say that we had to do the product. I know. Why are we getting complicated? Because it's fun. So negative 8 plus 9i. All right. Here we go. We have 7 plus 3i, all of that times negative 8 plus 9i. What are we going to do? Well, first things first, we have to treat it like a regular math problem. We're going to distribute our 7 to everybody and our 3i to everybody. Some people like to call that foiling, right? So it's whatever you like to do, you do, but you have to do it correctly. So I'm going to take my 7 and multiply it by my negative 8, and I'm going to get negative 56. I'm going to move it down a little bit. Negative 56. And then I'm going to take my 7 and multiply it by my 9 and get a positive 72i. No, that's not 72. Haha, just kidding. Just kidding. 63. 63. 63. I did the number trick. It's 63. Okay. Now, what are we going to do? We're going to take our 3 and distribute it. So we have a negative and a positive is a negative. 3 times 8 is 24. Keep your I. And a positive times a positive is a positive. 3 times 9 is 27. I squared. Remember, we treat them like x's. Nothing is different about these guys. They're just regular people. All right, so now we have 27i squared. Well, what do I do from here? Well, the best thing I know what to do is combine like terms, and then we'll figure out some stuff after. So when I combine my two middle terms, my I terms, I'll get negative 56, then what? Plus 39i plus 27i squared. Well, remember earlier we were talking about what I is? Well, I is equal to the square root of negative 1. Well, what is I squared? Well, that tells us that we're going to square this side. Well, when you square a radical, it kind of goes away, right? Goes away. So we'll have I squared is equal to negative 1. So anytime I see an I squared, I can replace it with a negative 1. So I'm going to replace that with a negative 1. So I'll have 27 times negative 1. Keep everything else the same. And remember, it's a positive right now. All right, we're almost there. 27 times negative 1 will give us a negative 27. Bring everything else down. 56, negative 56, plus 39i. We only have one last piece, right? And it's combine these last two numbers. Negative 27 and negative 56. If you owe me $56 and you owe me 27 more, it will be a negative $83 that you owe me plus 39i. Boom. That's the answer if you did the product of it. right? Little things like this is always good to know. Okay, so here's our function. I hope put your sleeves up. This one's going to be a doozy. I'm going to try to get this done in less than 10 minutes. Ready, set, what type of function is this? It is our fraction, which tells us that in derivative, based on calculus, it is going to be the quotient rule. If you do not know the quotient rule, I am not going to show you what it looks like. I'm going to show you how to use it. Why? Because I promise you will remember this a little bit more than trying to memorize the equation, like how to do it, all right? This is the function. The function is always called f of x. F of x is the same as saying y. We will now name our numerator f of x. I know this is going to get a little complicated. Our numerator will be f of x and our denominator will be g of x. Why do we do this? Because that is how you solve. Now what we're going to do is we're going to take f of x, which is the numerator, the green part, the numerator. I'm trying to keep them in the colors. 4x to the fifth plus x squared plus 4. We're going to take the derivative of that. How do you take the derivative of that? We've done it before. So the derivative of this is going to be 4 times 5 is 20, x to the fourth. 2 times 1 is 2x. Goodbye, 4. Now I'm going to do the denominator. The denominator we named g of x. F of x, g of x. All right, let's get to business on our g of x. G of x is 5x squared minus 2. All right, you take the derivative of that and you get 10x. That's it, just 10x. Done. Okay, now here is the part that matters. And this is why we're not using the actual formula, because it's going to start getting messy very quickly. Okay? Listen to the words that I'm saying and watch the screen at the same time. I'm going to start with my g of x and go across to my f prime of x, my derivative of f of x. Okay? I'm going to multiply those two functions together. So I have 5x squared minus 2 being multiplied by 20x to the fourth plus 2x. Big thing to remember, I'm going to subtract. So remember, I multiplied those two guys together. Now, I'm going to look at my f of x and I'm going to go down to my g prime of x. And I'm going to multiply those two guys together. So we're going to have 4x to the fifth plus x squared plus 4. And multiply that by 10x. And that is where this comes from. And it's going to all be over the denominator of the original function, the denominator squared. So 5x squared minus 2 squared. Okay, this is not an answer choice, so we're going to actually have to do the math. I know, crazy. But what you do is you take your function, your f of x and your f prime of x, your g of x, your g prime of x. If you can remember to do the math that I just did, cross them to get them in those spaces, you will never have to memorize the formula. You will have to remember how to apply the stuff. You'll never have to memorize the formula. All right? Now we're going to do some moving and giving and all that stuff, and we're going to do it very quickly. I don't know why that is there. We don't want it there. All right. So what did I just have? I had 5x squared minus 2 times 20x to the fourth plus 2x minus 10x. The order doesn't matter because you're multiplying. Times 4x to the fifth plus x squared plus 4 all over 5x squared minus 2 squared. So you can leave the denominator the way that it is. What you want to do is multiply your numerator. So we're just going to FOIL these things out. When you FOIL, you're going to get 100x to the 6th plus 10x to the 3rd minus 40x to the 4th minus 4x minus all of these guys, 40x to the 6th plus 10x to the 3rd plus 40x, all over 5x squared minus 2 squared. Okay. The denominator is from the original function. So if you look up the quotient rule for deriving, you will see exactly what we did, but in the terms of f of x and g of x. So they will tell you g of x, they will tell you g of x times f prime of x minus f of x times g prime of x all over g of x squared. That is what we are doing. It's just what the function says. That's how you solve it. There's no like why we did it specifically. It's just what they tell us to do. So if anybody knows the derivative quotient rule, this is the rule that you do down here in purple. We are applying the rule without worrying about all of the variables per se. We're doing it without saying g of x, f prime of x, all that stuff. Right? And then I have to distribute my negative, right? So I'll get 100x to the 6th plus 10x cubed minus 40x to the 4th minus 4x minus 40x to the 6th minus 10x to the 3rd minus 40x all over, is your head spinning, 5x squared minus 2 squared. Okay, we're almost there. Now you're just going to combine your like terms. This is a 6, this is a 6, this is a third, this is a third, those thirds go away. This is an x, and this is an x. All right, now when we do this, what do we get? Our answer will be 60x to the 6th minus 40x to the 4th minus 4. Minus 44x all over the denominator. Hey, look at that. We did it in less than 10 minutes. And I explained it. So it's totally possible for you guys to do it on your test. This is one you're going to want to rewatch and redo. Okay, you know what I like to say. Thank you for being a part of all of this. Thank you for showing up. Thank you for all that you do. The Learning Liaison has more to offer than our videos that you see here. We have the live boot camp. We have boot camps, and we have some other stuff like online tutoring. So go check those out, see what you can do, and we are always here for you. See you soon.